Up to this point, we've learned about a few ways to organize our Python code. The first thing we did, well, we just wrote Python in a file, and that organizes it, right? Our entire code has been so far on one single file. So that was one way that we organized our code. Next, we learned about functions, and functions were used as a way for us to not write code that we repeat over and over. We could write functions that we can use anywhere we want in our file, so that we can call these functions over and over. And we can name the functions appropriately so that our code makes sense. And then we learned about classes, right? These blueprints that we can create objects from. We can instantiate new Python data types beyond the ones that they just gave us, right? Instead of just having dictionaries and lists, we can create our own custom ones, our own lists maybe that have extra features. And we're able to use classes to organize our code, to box them up, and give each class a certain method and attribute that packages it nicely for us to use. We also learned about functional programming and how, unlike, let's say, object-oriented programming, where we see a lot of classes, with functional programming, we just use a lot of functions, a lot of pure functions. And we have data that we just pass into those functions. And we organize things into small little pieces. All of these things were meant for us to keep our code clean, make our code more maintainable, thus keeping our code organized. Because as we write more lines of code, it gets harder and harder to keep everything in your head. If other people join your team to work on your project, they need an easy way to figure out how things are working. But we still have a problem. And that problem is that everything is contained in this one file. All the functions, all the classes we've been writing has been on just one .py file. But in real life, this isn't the case. We have a lot more code. And we can't just have one file with millions of lines of code. So how do we stay organized? Well, if we had multiple files of Python, like this, because our project is getting bigger and bigger, would this work? Is there a way for us to link all of these files together? As a matter of fact, there is. And this is very common practice all across industry. And we call this way of organizing code modules. And modules are simply, well, these files. Each one of these files, each .py file is a module. And by building these modules, kind of like we built different functions, kind of like we built different classes, because inside of these files, we can have classes, we can have functions. But we can also have different files, so a layer higher, to divide up our code. And in this section, we're going to learn all about modules and try to master it and see how we can write organized code. Let's have a look. You can see over here, if I click on files in our REPL, we have main.py. And every time I click run, this file got run. But what if we have more files? What if I add another file here, and we'll call it utility.py. So based on what I just taught you, these two things are what? They're modules, right? Main.py is a module, utility.py is a module. And when writing modules, we use the same principles as variables in Python, which is snake case. That is, if there's spaces, we use underscore, everything is lowercase letter. So how do we divide up these modules? And this comes with practice. When you're just beginning, it's hard to say, hey, what goes into what file, what goes into what file? But it's similar to classes, right? Similar to functions. We want to divide up our code into chunks that make sense. Again, let's say we're working at Netflix. We might have a file dedicated to videos. We might have another file or module dedicated to the login of a user. Maybe another file dedicated to analytics and figuring out recommendations for users. We want to group these classes and functions together inside of a file that makes sense. Now, one of the most common ways to use a module is something like a utility. Let's say we want to create a utility module. That is a module that has a lot of, well, kind of like a tool belt. Very simple functions that we can use all across our project, because we can imagine here having multiple files. So let's create a very simple example. I'm going to say a multiply function exists here, and this takes a num1 and num2. And in here, we're simply going to return num1 times num2, a very simple function. And once again, we'll also have a divide function. And yes, this is kind of useless because we can just use the plus or the divide operand in Python, but stick with me here. I'm trying to show you an example. All right, so num2. I'm going to return num1 divided by num2. Nice and simple. So this is our utility module that has all these functions for us. Now, notice here that we're actually not doing anything in this file. I'm simply defining functions, but I'm not running any of the functions. But let's say we have this utility module and I want to use it in my main.py file. How would we go about doing this? Well, the way we communicate between these two files is quite simple. All we need to do is use the import command. We import and then give it the file name that we want to import. What do we want to import? We want to import utility. Just like that. And notice that I'm not adding the .py because we assume that whatever we're going to import is going to be a Python file. So we don't need to do that. Just the name. Just like that. Now let's print utility here. If I run this, whoa, did you see that? We have module utility from, and then this is a file path that this website generates for us. So it doesn't really matter. Now, there's a few things that happened here. One is that we generated this PyCache folder, __ PyCache. And oh boy, what is this gibberish? This is pretty confusing, right? Well, this PyCache is created every time we run a file with, let's say, import statements. So when we're using modules. You see, what PyCache does is when we click run, the interpreter is going to create this PyCache folder and it's going to say, hey, I'm running this file, this one main.py file. Anything that main.py file imports, let's say utility in our case, I'm going to cache it. So see how here it says .pyc? This is because it's using the C Python interpreter. Remember? This is the C Python, which is the interpreter written in C. So this is actually a compiled file. So that next time I click run here on my main.py, nothing changes. Because what's going to happen is instead of loading up utility.py, it's going to load up this compiled version of utility because nothing has changed in utility.py. And this makes things faster when I try to run main.py again. That's what caching is. Caching is, hey, I'm going to remember this and this is the compiled version so I don't have to go through the compilation step again. But notice that the main.py file does not get compiled because, well, we run it every time. Now, if we change the utility function to not have the divide in there, I click run, and you don't notice it here, but this has now been rerun because we have a different file. You see that we have multiply here, but not divide. So let's bring back divide again. Go back to here, click run. And there you go. We have divide here too now. But this is something that we don't touch. This just comes underneath the hood with any editor that we use. And in a few videos, we're going to show you how this also happens when we use something like PyCharm. This is just something that editors allow us to do just so our programs can run faster. So I now have access, let's make this a little bit smaller. I now have access to utility. And here's the interesting part. If I do dot here, look at that. I have access to divide and multiply so that I can multiply numbers, let's say 2 and 3, click run. And I'm able to use the utility module in my main file. Very, very cool. If I do divide and I click run, I can use this as well. Very, very cool. And I can import as many times as I want. If I had a different file in here and I want to import another thing, let's say there's a utility2 file. Well, I can import that and import as many things as I want and use them across my files. How cool is that? So now we have a way to organize our code and have all these files communicate together. Because in real life, we have big projects. And these big projects are going to be worked on by different teams, different programmers. And we need a way to work with all these files. And by using the import statements between modules, we're able to use functionality, just like we were able to use the functionality that functions provided us between different files. And most of the time, if you're working at a company, the first couple of lines on a .py file are usually import statements because usually you're communicating with other files. Let's learn some more in the next video. Welcome back. We just learned about modules, but let's say our project is getting even bigger. We have this main file, we have some utility, but let's say that we're now working for Microsoft and we have a new, let's say, shopping functionality, an entire, let's say, shopping area where you can buy Microsoft t-shirts. Well, we can now create a folder, so we can add folders to our project. And inside of this folder, let's say we have a new file, and we'll call this the shopping cart.py. So now this shopping cart.py is a folder in our project. You see that our project is getting bigger and bigger. And let's say that here we just have a function called buy, and we give it an item. And let's say here we have a cart variable that, let's say, adds. It's not a very sophisticated buying system, but for our example, it should be fine. And then we just return the cart. Now in here, we have this buy function. And let's say in our main file, so up here, we want to also import our shopping cart buy function. How can we do that? Well, if we try to do shopping cart like this, remember that's the name of our file. You see that I get an underline that says imported but unused. Okay, so does that mean I can use it? Let's see. I'm going to say shopping cart, and if I click run, module not found error. No module named shopping cart. You see, what we've created here is what we call a package. A package is simply a folder. And we learned about module, which is these files, these Python files. A package is a level up. A package is a folder containing modules. So you can have a package with multiple modules inside of them. So this shopping cart is a module, but this shopping is a package. So the way it works when we import from a package is we say the package name. So what's the package name? It's shopping. And then we do a dot. So dot shopping cart. So package name and then the module name. Now if we do this, let's see if this works. Let's say I do shopping dot shopping cart now. If I print this, let's make this a little bit smaller. All right. Now I have access to the shopping cart module by importing the package shopping, which is the folder, and then the shopping cart. And you notice once again, we have a PyCache that was created for the shopping cart. So let's see if we can use the buy function. So I'm going to say buy, and then item, I'll say I'm buying just an apple. If I click run, there you go. I get my apple list, and I was able to import it from a package. Now, here's the thing. I want to try and copy what we've just done into a real life scenario. Instead of using this website, REPL.it, let's actually create our own project. I'm going to use PyCharm, and I recommend you use PyCharm as well, just for these next couple of videos. Let's open up PyCharm, and let's just create a new project here. Now we can call it whatever we want. So let's just call it modules for now for our project. You can see where it's being saved. And remember here, we get to pick what interpreter we want. We're going to talk about this virtual env later on in the videos, but the key thing is to make sure that our base interpreter is using Python 3. In my case, the Python 3 that we've downloaded in user local bin. If you're on a Mac or Linux, if you're on Windows, this path will probably be different. Now we can just create a project. And we see here we have our modules project. Now we're going to ignore all of these folders for now. We're going to talk about them later on. The key here is that we want to create a new file. I'm going to just right click here and say new Python file. And we can just call it, let's say, main.py. And notice here that I created in a folder called venv. We'll get back to that shortly. Now let's make this a little bit bigger so we can see. And we're going to copy whatever we've just done here. So I'm going to copy the main file like this. Oh, that did not copy. Let's try that again. Like that. And then we're also going to create a few more files. So we'll create a folder. So in here, I'm just going to say right click, say new. And right away, you see that it says Python package. I'm going to click on Python package, or I can create a directory if I want as well. And when I click here, let's name the package like we've done here as shopping. All right, we get our shopping folder. And in here, let's right click, say new file, and we'll call this the shopping cart.py. So shopping cart.py. And then finally, we'll add our utility file. I know we're doing a lot, but hey, I'm trying to prove a point here. Trust me, this is going to be important. So utility.py. There we go. So we have the same setup that we have here. Let me copy this over as well. All right. And we copy. Let's make this bigger like that. All right. So we have our files just like we have in our REPL, except this time we're actually using an IDE. Now, the reason I wanted to transfer over to the IDE is that there's an extra file here that we didn't see in the REPL. And the REPL actually hides this away from us. You see this underscore init.py file? And it's completely empty. There's nothing in here. One of the rules of a package, of a Python package, is that on the root of this package, you have to have an underscore init __.py. Now, why is that? Well, because the interpreter is going to read this and say, oh, this is a Python package. Remember how when I right-clicked here, I said new, and then I had an option of a directory or a Python package? By clicking Python package, it automatically added this init for us. So although here everything worked without a init, this is just something that REPL hides underneath the hood. Anytime you want to create a package, you'll see that we need to have an init file. and it can just be completely empty. Now, the beauty here with PyCharm is that it does it for you, which is really, really nice. Okay, so let's run this code and make sure that it still works. So this is our main.py. I can simply run the code here by going to run and then selecting run. Let's run our main file. Oop, and we get an error. Let's zoom in here. And we see that module shopping.shoppingcart has no attribute by. And that is because we did not import the by function here. So let's do that. Let's go to shopping cart, by. Make sure I copy that. Paste it in. Let's zoom that in. And by the way, I'm zooming here on my touchpad. I can just use 2 fingers to zoom in here. If I click run again, and this time once you ran it once, you can just click on run again. And there we have it. We have Apple right here as the output. And it says process finished with exit code 0. In programming, when something exits with code 0, it means there were no errors. If you get 1, well, that's usually an error. All right, so we have everything working, and this is now our setup. We have our main file. We have our other modules like utility. And then we also have our packages, and they're packages because they have this init file, and we have different modules in them. And as projects get bigger and bigger, and we use IDEs like PyCharm, we organize our functionality, our grouping, into these packages and modules. And really, really good developers are able to organize code in really nice packages that make sense, really nice modules that make sense. This is a skill that is really hard to teach. It just comes with practice, by looking at other people's projects, by working on projects. But the key thing is that you want to do what makes sense. And when we start working on some of our final projects, we have over 10 projects coming up that we're going to work on. Now, with those ones, you're going to start to learn different ways to organize code as you follow along. So don't worry. Let's take a break and explore modules a little bit more in the next video. Let's learn about different ways that we can actually import these modules. Up until now, we've only learned about import. But sometimes things can get pretty hectic. For example, we can actually have another package inside of another package. If, for example, I create a new folder here and say new Python package, we'll call this more shopping. Click OK. You see that I've initiated another package inside of a package that has its own init file. And let's move this now to, let's do refactor, move, and we'll move it inside of the more shopping folder. So I'll say more shopping. If I click OK, you'll see that I've moved this module over here. So I have a package inside of a package. And the way we would access this is to say simply shopping dot more shopping dot shopping cart. And let's copy that over and do the same here. And now when I click run, you'll see that it still works. But this is getting a little bit too crazy. You can imagine as we have more and more packages that we constantly have to do this dot, and this is getting a little too long and ugly. So how can we better this? Well, one way of doing this in a cleaner fashion is to do something like this. Instead of saying import, we say from this part, I want to import the function. So here I'm saying, hey, from package name module, import whatever function I want. In our case, we want to import the by function. So you see here, I can just do that. And in my code, I can just run by as if it was part of this main file. If I run this, you'll see that it still works. Awesome. So that's definitely cleaner. And we can do this with utility as well. I can say from utility, import and actually import the two files or the two functions. So that is multiply, and if we want another function, we can just add a comma and say divide. So now we can print apple or buy apple as well as divide. Let's say 5 by 2. And we can also multiply. Oh, and make sure it's a comma here because it is a function like this. So that if I run this, you'll see that there we go. This works as well. So this is a really nice way to clean up your code. You can also do something like this, where you say from package name, and then import the entire module. So let's say I want to import the shopping cart module. I can say import, so package.package, or you could have just have done one package, and import the actual module shopping cart. So now I would access it like this, shopping cart.buy. And this is going to work as well. Perfect. Now, the reason you might want to do this instead of what we had before is that sometimes you can get name collisions. Let me show you. Let's say I had a print, and then in here we use the max function, which gives us, it's a built-in function, we give it an iterator, and it finds the max for us. So that if I run this, you'll see that the max in this list is 3. Well, imagine in our utility function, we have a, let's say instead of divide, or we add a max that simply says, returns an oops. Well, if I go back to my main.py and get max as my function, and I click run, well, you see I get an error. I get max takes 0 positional arguments, but 1 was given. Because now max doesn't mean what we thought we meant, at least in this file. We've imported max, and well, max is a whole different function now. So we can actually override existing functions. So by using something like this, shopping cart, we make sure that we have only one case that we might have name collision, but all the properties or all the methods that shopping cart has are connected to shopping cart. So instead of having multiple functions that could be overridden, I only have one namespace. And by the way, this is also one of the reasons that I don't recommend doing something like this. You can actually do import star. And what this says is, hey, from the utility module, import everything. And when you do that, you'll see that once again, we get an error because it imports the max as well. And because we don't even know what's being imported right now, we can't see it. We have to go to the file to see it. When we get an error like this, we're going to be like, what's going on? I thought max is working. And it's because of this line. So it's always good to be explicit and say exactly what you want to import. But let's remove max for now. But as you can see, modules can be imported in different ways. My recommendation is to always be explicit and say exactly what you want to import. And the format usually follows either using the import statement followed by the package.module or import the module, or you can do the from statement to give it package, subpackage, and module if you want, or you can do module and then saying import and the specific function or the actual module itself. Many ways of doing it depending on your need. The key takeaway here is that modules and packages help us have good engineering practices and build big projects in an organized fashion, yet still have all these files talk to each other. All right, that was a lot. Let's learn more in the next video. Welcome back. In order to finalize our understanding of modules, we have to talk about an important concept, which is this idea of main, or specifically __main. Because as you start developing in your career, you're going to start to see a lot of code like this. Now, this is one of the most common lines you're going to see when working with Python. And in this video, I'm going to explain what it does because it is one of the most confusing topics, especially for beginners. So for now, I'm going to comment out and do a few things. We have our main.py file here, and I want to do a few things. First, I'm going to open up our shopping cart, which is right here. And at the top over here, I'm just going to print, because right now our file isn't doing anything. I'm going to say print underscore underscore name, like this. And I'm going to do the same for the utility.py. So at the top, utility.py. Now, if I run main here, let's click run here, I get these two things printed. Now, why is that? Well, when I run a Python file, usually we just run one file, right? The main file that we're working on. In our case, our main file just happens to be called main.py. So when I click run, the interpreter goes line by line through here. The first thing it does is import the utility module and import these two files. So what it's going to do is go to the utility file and run this. And automatically, each file that we run, or each module, is given a name. In our case, it's the name of the module, utility. So when you import something in Python, it finds the module, it runs the code, so it adds this code to memory because we're going to have to use multiply, divide, and max, and then goes on to the next line. In our case, it's this one where we import again from the shopping cart. So it's going to say, hey, the name of this is shopping.moreshopping.shopping cart because that's the module name. And then finally, it's going to go through here because by this point, by line 4, these files have been run and they're in memory now. Now the interpreter has access to divide, multiply, and all these functions that we've imported. Now, here's my question. What if I do here, or at the end, do print underscore underscore name on this main file? If I run here, you see that I get underscore underscore main. Is that what you expected? What if I change the name of this file? Let's say refactor and say rename. Yeah, that's okay. We want to rename it, and we'll rename it to, let's say, test.py. So now this is called test.py. What do you think the underscore name of this is? If I run here, I still get underscore underscore main. So maybe this is starting to make sense now. When you see the code this, if underscore underscore name equals to underscore underscore main underscore, so these are dunders, then do something. And this, the name main is given specifically to the file that we run. Because remember, when we run a file, when I do play, or when I do in my terminal, Python 3, and then say test.py, I run that one single file. And that one single file imports different modules and runs them. That one file that we run gets this default underscore underscore main. So the reason you might see lines like this in Python is that sometimes we want to make sure that we run a module only if this is the module or the main module. So I can say here, print, please run this. And let's remove this print for now and click run. You see that this, I get, please run this. But if I copy this code and let's say put it into utility, like this, and I click run, you see that please run this does not appear in utility, only at the end when we're running this test. Because why? Well, the name of this file is not main. The name, remember, is utility. So this is a good way for us to only run code of the main file. So this is a common structure as projects get bigger and bigger. Maybe we have code that we don't want to run unless it's the main file. In our case, let's say that we don't want to run any of these unless this is the main file being called. If I run this now, you see that, and I get an error. It says line 1 in module cannot import name multiply from utility because, well, we aren't able to import this because we didn't run this piece of code. So let's revert that back, come back here, and what we can do now is actually wrap this entire thing like this, so that we make sure that test only runs if, well, that only if this is the one being run. It shouldn't get imported. It should just be the main file that we run. Now, remember when we had a class? Let's say we had a main file and we created a class, let's say student. And this student, let's say, doesn't have anything, but when we do type of student and we do print here, and I click run. Let's instantiate the student. So let's say student1 equals student. And let's just get the type of the student. If I click run, do you remember how we have this underscore underscore main dot student? What it's saying is this class was created in the main file that we ran. If, for example, I copy this, added it to the utility like this, and now in my main file, I import utility, and let's say utility.st1, and do type, and then print. What will happen then? Well, we get class utility.student. So whenever we saw that main, all it was saying is, hey, this was a class that was created in the main file. Again, this is one of those things that you're going to see a lot of, but at the end of the day, all it means is I want to make sure that if this is the file that's being run, because a file can be either run or it can be imported, if this is the file that gets run, it's the main file, then do something. So it's a good way to check how our modules are being used, whether imported or ran. Hopefully that made sense. In the next video, we're going to talk about something exciting called built-in modules. I'll see you in that one. Bye-bye. One of the key features of Python is that the core language that we've been learning up until now is pretty small. As a matter of fact, we've pretty much covered most of Python. Now, Python was created in this small, tiny package as a feature to keep things simple. Although you may feel like you've learned a lot, at the end of the day, it shouldn't have been that bad because there's not a lot of things to memorize. We also learned how to organize our code so that we have multiple Python files. But the reason Python is so popular, and it's used in all sorts of industries, from big tech companies like Google and Netflix to Amazon, to small projects and people like us who just maybe are single developers building tiny projects. Python is extremely useful through what we call external modules and packages. That is, outside of what we get from Python, well, we have an entire package system where we can borrow and expand on the Python functionality. And these are called Python's built-in modules. Let me show you what I mean. If you go to the Python documentation, they have the Python module index that I'll link to. And here we have all the modules that Python give us. Now, these modules actually were installed when we downloaded the Python interpreter. It comes with Python, but in order for us to use them, we have to import them. These are the built-in modules, and they're really, really nice. For example, do you want to send, I don't know, an email? Well, there's an email module. Maybe you want to really do some mathematical operations that are complex. Well, there's a math module for that. And there's a module for a lot of things. Now, don't get scared. This looks like a lot, but you're not supposed to memorize any of these. You just need to know that they exist so that when you're Googling something, you can type in Python built-in module. And let's say, for example, you want to build a game. Say Python built-in module game or graphical user interface, and check if the module exists. I have to say, I've probably only used 30% of these, but they're there for us to gain extra powers. In other languages, this might be called a standard library. That is, it's a standard library maintained by the Python community members, and making sure that these packages work really, really well with Python and that they're built into the language. So let's learn how to use them and use one of my favorite ones, which is called random. So let's see here if we can find it. random. Generate pseudo-random numbers with various common distributions. And you can read all about it here. It's a long read, so let me just show you. Now, the beauty is that we've actually installed this. Whenever you install Python on your machine, you get access to all the built-in module, the standard library. So all I have to do is say import random, and now I have access to random. If I run this, let's click run. Look at that. Module random from library frameworks Python. You see that it's in versions 3.7, library, Python, and random.py. This is actually installed on my machine, and it should be installed on yours as well if you followed along and installed the Python library. Now, where is this? Where you can actually see it in our PyCharm. If you go to external libraries here and you open this up, you see here that I have the Python 3.7 modules. And if I scroll down and you go to Python 3.7 or whatever your installation was, and scroll all the way down to, let's say, R. Where is it? Where is it? As you can see, there's a lot. Here it is, random.py. This is installed on our machine. And if I double click this, look at that. I have the random variable generator, and this is the file that allows us to use random. And you can see over here that random is a class that is going to allow us to, well, use all this functionality. And look at that. It even has this little line that I told you about in the previous video. Only run this test function if this is the main file run. This is probably something that the maintainers of this module, whoever coded this, added to say, hey, don't run this for anybody else, but if, for example, we're working on this and we want to run the test function to test that all of these things are working, then run that. But in our case, when we use random as users or consumers of module, this is never going to run. Very, very cool. Now, you can see here how many modules we have. And we even have some packages like the email package with, well, a whole ton of things. So this is already existing in our computer. And that's why we have access to import random. So let's learn more about random. Now, what I like to do usually when I'm importing a library and I don't know what it does is to actually use the help function that comes with Python. If I run this, you'll see here that I'll get a help message with, well, all the information and documentation of what it does. So it gives you some description. If you scroll down, it shows you some of the code and some of the methods that perhaps we get, which is really, really nice. Let's lower that down. Another thing that I like to do after perhaps I read the documentation is to do the dir function. And if I click run, and let's actually print that. If I click run, here we go. It shows me all the methods available on this package. So I can see, all right, all these things that I have rand range, sample, seed that I can use. If you're using an IDE like PyCharm, I could just do dot and actually see all these methods as well, which is really, really nice. All right, let's have some fun with this random module. Random has, randomly, a random method. So random.random is going to give us, well, let's print it out and find out. It's going to give us a random number between 0 and 1, as you can see here. So this is really useful. Another thing it does is it gives you a rand int, which is a random integer, and we can give it the first parameter, where it should start and where it should end. If I run this, look at that, I get 4, then 1, then 6, then 2, just a random integer every time between the start and the finish. Another useful one with random is something called choice. And here, inside of the choice, we give it, let's say, a choice to make. For example, a list, 1, 2, 3, 4, or you know what? Let's do 4, 5. If I click run, it just makes a choice. Picks one from the iterator list that we have, which is really, really nice. Just random choices. So why is this useful? Well, maybe you want to build, I don't know, a roulette game, or a game where you need a random generator between, let's say, number 1 to 10. So this is a nice way to just do that without coding it yourself. Another one that I like is called shuffle. And shuffle, if I click run here, I'm probably using it the wrong way. So how can I find out more about this? Well, this IDE allows us to actually select and do view quick documentation, which you can see is F1 in my case. It might be different based on your machine. So I can just say F1 and look at that. Well, I see that shuffle has the sequence X in place. That is, it modifies whatever list we're giving it in place, so it returns none. So what we need to do is, let's say my list, that will be 1, 2, 3. Let's add a few more, give my list in here. And instead of printing that, after we've shuffled things, we'll say my list and then just print this. If I click run now, there you go. I've shuffled my list in place. Very, very cool. Now, another import thing that I haven't shown you yet, and you don't see it as often, is to actually do something like this. I can say from random import shuffle, or I can actually do an alias. So I can say import random as, and then give it an alias. That is whatever we want to call it in this file. So let's say ooh la la. So in that case, random becomes ooh la la. So you can actually avoid name collisions if you want. So if I click run, this should still work. But again, a good practice for me personally is to always import only what you need. In our case, we want to import from random just the shuffle. So I'm going to say shuffle because I'm being explicit here, and when a developer comes and sees that I'm importing shuffle from random, they know that I'm only using this function from the random file, and there's no guessing involved. Just like this. Let's learn some other built-in modules in the next video. Welcome back. I wanted to show you one other package. Mind you, we have a video coming up on useful built-in packages in Python, and we'll go over some of my favorites. But I want to show you one that's a little bit different than what we've seen, which is random. And this one is called sys for system. Now, import sys, if I do something like, let's say print sys, and I click run, I get a module sys built in. And sys is a really, really useful one that you're going to see a lot of. Now, with sys, you can do something really interesting. For example, sys has something called argv. And argv gives you some interesting powers. You see, up until this point, we've just kind of ran our code inside our IDE. But what if we had a terminal here on our desktop? And by the way, see over here that we have the venv. Again, something that we'll cover, so don't worry. Now, in here, I have a 1.py file, which is completely empty. It doesn't do anything. So let's just open that up. I'm going to open it up with Sublime Text just because it'll be easy. And in here, I'll just say print hi. So this is a Python file that lives on my desktop. So I'm going to save that. And imagine here that I did Python 3 and then do 1.py. If I ran this, I get hi from my terminal because this file's on desktop and I ran the Python interpreter on this. But what if I wanted to do something interesting? What if I wanted to give parameters to this file? Perhaps say that my name is Andre. Well, with sys.argv, we can actually access those. And I can give it as many parameters as I want. So let's give it another one like this. Let's go back to 1.py. Once again, open up with Sublime. And in here, I'm going to import sys.argv, and I can access these parameters like this by an index. So 0 index will be Andre, and 1 index will be Nague. So let's try that. I'm going to say first equals sys.rgv 0, and then last will be sys.rgv 1. So that now I can do an f string and say hi first, then last. Just like that. So if I save this and now go back to here and ran my file like this, all right, I get hi 1.py Andre. And I made a little bit of a mistake here. It looks like the first index is actually the file name. And then you get the optional names. So it's an easy fix, right? All we have to do is say 1 and 2. If I save that and click run, look at that. I get hi, Andre, Nague. Now, using this knowledge that we've gathered so far, I want you to use the built-in module, this sys and the RGV, to build a game. I want a game where I can run it like this from the terminal or the command prompt, where it's going to ask me for an input and say, hey, guess a number between 1 and 10. And it's going to let me keep guessing until I get that number right. So you might want to use, I don't know, the random module that we've learned. So take a break, try to create that. Now, this game, beyond just asking for a user's input and giving you a guess, 1 to 10, can also be customized. So that instead of just, let's say, running the file, I can also do something like Python 3, run the file. Let's say that this test file is going to be called randomgame.py that we're going to write. And in here, I can give it options of, let's say, 1 and 100. And this program is going to take, using sys.rgv, the number from start to end. So this game is going to be really difficult because we're going to try and guess a number 1 to 100, or 1 to, let's say, 2, which makes the game really simple. So again, The goal is for you to write a program, call it randomgain.py, ask a user to guess a number, let's say between 1 and 10. Get that information, try to randomly generate a number 1 to 10. The user is going to be asked when I get prompted, hey, I want you to guess a number 1 to 10. And from there, we're going to keep guessing until I get it right. And hopefully at the end say, you're a genius. Or if I keep getting it wrong, well, it's going to keep asking me until I get it right and maybe do a couple of validation as well to make sure that the user actually enters what we want. Good luck, and I'll see you in the answer video. Welcome back. How did you do with the random game? Were you able to solve it? Let's give it a try here. Now, I'm just going to use the test.py. Actually, let's just rename it, just so it's not confusing. I'm going to rename it to random game.py. All right. Now in here, I want to be able to, first of all, well, let's think about what we need. So the first thing we need is to generate a number 1 through 10. Then what we need to do next is to get an input from user, right? And then we want to do some sort of an input check. So let's say check that input is a number 1 through 10. And then check if number is the right guess. Otherwise, ask again. So that seems like a good program that we can write. So how can we do this? Well, the first ask is to generate a number 1 to 10. I know that I'm definitely going to want to import the random library from here, and specifically the rand_int. So I can just say from random import rand_int, which we've seen. And here I can generate the numbers. So let's call it the answer is going to be rand_int from 1 to 10. So this is going to be our machine generated random number that we need to try and guess. Next is we have to get the input from the user. So how can we do this? Well, simple, right? We can get a guess as input from the user, and we get the prompt. So we'll say, guess a number 1 through 10. All right, so that's looking good. What about check that input that it's a number 1 to 10? So we have to do a bit of checking here. Now, because we want to keep looping while the user is guessing, I'm going to do a while true loop that we have to make sure we break out of so we don't have an infinite loop. And in the first part of the while loop, I want to check what the user inputs. So I'm going to say if guess, well, we know right away that the input is going to give us a string. So we have to make sure we convert this into an int first. So let's do that. I'm going to say if int guess is greater than 1 and int guess is less than 11. So in our case, let's do 0 here because we want to make sure that if it's 1, it's still good. If it's 10, it's still good. In that case, well, we can actually try and check if it's the right guess. Now, what happens if this fails? What if the user enters a string that can't be turned into an int? For example, if I go to my terminal here and I just turn on the Python interpreter and say int and then just give it some gibberish, I get a value error. Invalid literal for int with base 10. I have no idea what you're trying to do. So we can check for a value error here. So what I'm going to say is to try this bit of code. And for now, we'll just pass in here. And if for some reason it doesn't pass, and we'll check for value error, then I'm going to print please enter a number. Awesome. So we're checking that the input is a number 1 to 10. So for now, just to make sure that this is working, let's just do this. Let's break out of this loop, or print all good in here, and break out of this loop, considering that right now we're entering a number 1 to 10. And let's just make this a little bit smaller just so you can see it better. There you go. And for here, we'll just do continue, because we'll just keep looping until we get the right answer. So again, we're importing randint, generating some random number, 1 to 10. We're getting the guess from the user, and then we want to check that the input is a number 1 to 10. So I have a loop that I'm going to keep running, and I'm going to ask, is the number 0 to 11? If it is, then we're all good. If for some reason we get a value error, then we're going to say, hey, please enter a number. So let's just test that out. I'm going to go to my terminal, or actually we can just run this here. Let's run it. All right, guess a number 1 to 10. 5. And I get all good. Like, I think we need a couple of spaces here. It looks a little weird. So let's just say, guess a number 1 to 10. And give some spaces. Let's run that again. There you go. And I've actually already noticed a bug that we need to fix. If, let's say, I enter gibberish. Oh boy. I get, please enter a number, please enter a number. And we need to stop this because it's going to get destroyed. All right, so what happened here? Well, we didn't break out of this loop. We continued. And we just kept going while true, while true, while true. And we kept getting a value error. So you have to be careful here. Remember, when we continue, it goes back to the try block or back to the while loop, and it's going to try this again. But we're not asking for the input or a new input again. This is going to fail, and then another value error happens. And then this is going to fail, another value error happens. So we need to put the guess inside here, right? Inside of the try block. So now if I run this, all right, let's guess a number. Let's give gibberish. I get, hey, please enter a number. All right, we'll enter a number. We'll enter, how about 0? Nope, this doesn't work. It's going to keep asking me because, well, the number that we entered, it's less than 1 to 10, but it's a wrong answer. We could check is wrong. You know what? Let's do that. Let's say else. We'll say, hey, Bozo, I said 1 through 10. That'll be a fun one. All right, let's run this. Let's do 0. Hey, Bozo, I said 1 to 10. All right. Let's do 5. Hey, I guess the number 1 to 10. Everything's good. All good. All right, so now what I'm going to do is just see if the guess matches whatever the answer right here is. Now, before I do that, you see here how the PyCharm IDE gives me a little hint, a yellow line that says, hey, this simplified chain comparison can actually be improved. It's why IDEs are so powerful. And here I can actually simplify this. I can say if int guess is higher than 0 and less than 11, then do this. And look at that. I just simplify my code, and the editor gave me a nice hint. Okay, let's go through here. So instead of saying print all good, let's say if this is the case, we're going to have another conditional and say if the int guess equals to the answer, we'll print you're a genius. And we'll break out of that. Now, notice here how we're doing int guess a couple of times. Maybe a better way of doing it is to just do an int here so we don't repeat ourselves and run the same function over and over. And just have guess like this. So again, we're cleaning up our code, making it read more like English. That's nice. And now if we run this, guess a number, let's say 5. No, that's not right. Let's do 6. What about 7, 8, 9? This guy's a tough cookie. 1, 2, 3, 4. Oh, come on. Is it 10? Wow. We are definitely not geniuses because we just, well, tried 10 times. But this looks like it's working. Let's make sure that we're actually working this properly by cheating a little bit. I'm going to actually print out here the answer. So I see what the answer is before I type it in. Let's do that actually right here. If I click run, all right, the number is 4. If I type in 4, all right, now I'm a genius. First try. All right, we're cheating, but it looks like this is working. That's pretty cool. Now, the last part here is that up until now, I've used the input, but I said I wanted to run it in a terminal. And I want to be able to actually, well, give it parameters, right? We give it the start parameter and the end parameter of randint. So we can make the game as hard as we want. So that's pretty simple. We have the import sys here. And we simply say sys.argv. The first parameter, remember the first one's going to be the file name. And then the third parameter. And that's going to be the numbers that we're giving it. So let's use this file now. Let's copy the code. And just for this example, because it's simpler, we'll just add it to our Sublime text file. Oh, and looks like we have to do sys.argv here as well. Make sure we don't forget that. So let's fix that as well. Like that. That's better. And if we run this, not int, because remember the parameters that we're going to give it are going to be turned into strings. So we just have to make sure that we convert this into an int, like this. Now if we just copy this, run this over here, let's run it again. So I'm pressing up here because it remembers my previous command. Let's give that a go. Guess a number, 1 or 2, let's go with 1. There you go. I am a genius. And our program is now working. Our guessing game is now working. Very, very cool. If you got this, good job. If you didn't, well, you can just take a look at my code and hopefully see where you went wrong. But good job getting this far. I'll see you in the next one. Bye-bye. Up to this point, we learned that the power of Python really comes into play when we talk about modules, but more importantly, when we talk about the standard library that it comes with. That is, the ability for us to have these built-in modules that we can just import into Python to extend the language and have things like random module, the sys module, to be able to use in our code. And these were called the standard library. But the true power of Python, and I argue the reason that Python is such a big part of any company, really, in this day and age, and why Python has just exploded in popularity, is because of this third part. It's because of developers like you and I who have the ability to create our own Python files, thousands, millions, trillions of Python files, and actually share them with each other so that we can actually, instead of just having our own code, our own standard library code that we download with our Python interpreter, also have all the code that others share on the internet so that we don't keep reinventing the wheel. If somebody else wrote a really, really good module that maybe can be used in another project across the world, well, they can share it and we can download that module and import it into our projects. And that's why really amazing libraries like NumPy, Pandas, TensorFlow, all these things that we're going to talk about later in the course are libraries built by the outside developer community. Not the Python community, but in general, just developers like you and I, or developers working at Google. It could be developers that are working in South Africa, that are working in Fiji. It doesn't matter. We're able to use each other's code. And we're able to do that using the pip install command. And in these next couple of videos, you're going to see the true power of Python, how we're able to stand on the shoulders of giants, learn from previous mistakes so that we don't constantly reinvent the wheel. If we want to build a game, if we want to build a website, we don't have to code it absolutely from scratch. We can use bits and pieces, modules and libraries from all these different parts to combine it so that we can fast track and build our project even faster. So how can we do this? How can we use this knowledge base of the world? Well, we have a website for that. It's called the Python Package Index, or PyPy for short. As you can see, pypy.org. And right now, there are 182,000 projects, 335,000 users on this website that have shared code that you can use. Unlike the Python module index, which, had a lot, but that's it. This has a lot more. Let's say I wanted to do email. Well, look at all the packages that I have for sending email with my code. Let's say I wanted to do, image optimization with code. Well, look at that. All these packages for image optimization that I can do. What if, for example, I wanted to, read Excel files or CSV files? Well, there's packages for that as well. And there are a lot of them. Pretty much anything you need, you can probably find on here. Now, a good practice is to first check that something exists in, the built-in module. Maybe the standard Python module, standard library has it already. Otherwise, you come over here. Now, you get really, really good at noticing which projects are good, which projects are bad. For example, if I click on here, I can read about the project. I can see who's worked on the project. I can see what kind of license it has. I can see what Python programming language version it's compatible with. But I can also look at the release history and see, has this person been working on this project recently? Doesn't look like too much has happened with this project. So you get really, really good at deciding which packages are good, which ones are bad. You can go to the homepage of the project. What I like to usually do is, let's say I wanted to read CSV files. I would say read CSV Python 3, and then say maybe built-in to see if there's any built-in modules. And I see over here that there's some Python documentation, official documentation that maybe I can read. And I see that it has import CSV. So I can go to over here and just check, hey, is CSV actually a built-in module? Oh, yeah, looks like it is. So I probably should use that because, if it's a built-in module, I'm sure the Python community has worked really, really hard to make sure that it works well. But maybe I wanted some extra features that I can't find here. In that case, I would just go back and maybe type in, instead of built-in, PYPI. And now I can just browse through these and see which one I like. There are so many packages that you can do pretty much anything you want. That's the beauty of Python, this massive community. And it's not just Python. There's communities like JavaScript that use, instead of PyPy, they use NPM. You have Ruby developers that use something like Ruby Gems. This is what programmers do. They share code so that others can use it. And most of these are just completely free to use. You can use them in your code and not have to worry about it, which is really, really nice. And on top of that, you can also create your own packages. If you wrote a really, really nice module that you want to share, you can publish your own packages to the Python package index. But enough talk about this. Let's actually learn how to use this power, how to install something from third-party developers that we can use in our program. And by the way, I'm about to show you a few little packages, but in our final projects, when we build over 10 projects, we're going to be using a lot of these. So we're going to learn a lot more later on in the course. So don't worry, I'm going to cover some really exciting ones like texting, email, reading PDFs, checking out images, and machine learning, Excel, and a ton of things. So bear with me as we start to learn about pip install. Welcome back. I just found this Python package, PyJokes. And mind you, I have never installed this, so I'm going to try and do this from scratch so you can see what the steps would be like. So this is a completely useless package. It looks like it gives us one-line jokes for programmers, so I think this will be appropriate. I also like the fact that it has GitHub stars. So here, sometimes some of these packages are hosted on GitHub. And GitHub is essentially a social network for programmers. You're able to put up your code up here and people can view your code and download it. And a good measure of how popular a package is usually something like stars or forks, because stars are given by people that really like the package, or fork is people who copy the package and use it in their own coding, maybe on their own GitHub profiles. So this looks like a very simple library, so let's install it. So there's several ways that we can actually install this package. You can see here that the command is pip install pyjokes, but I want to show you first how it works with PyCharm and then show you how to do it with the command line. So I have PyCharm over here. We have some relics of our old project. Now in here in PyCharm, again, it's an IDE, so it comes with a lot of built-in things. I can do PyCharm, preferences, and then simply go to project modules. I can go to project interpreter, and then here I see that this interpreter has some modules already pre-installed. I see that I have pip, but all I need to do is click on the plus sign here. If I click plus, I can actually here search for packages. So these are all the available packages that we have. So what was our thing called again? PyJokes. All right, let's search for PyJokes. PyJokes. There it is. I think it was this one with 0.5. With the author, PyJoke Society, just making sure that it's the same one. Yep, author, PyJoke Society. So all we need to do here is to simply install package. There you go. PyJokes installed successfully. So now that I have PyJokes here, let's have a look at how we can use it. By the way, I can actually test to see that I have this installed. If I go to lib, Python 3.7, site packages, there's my PyJokes distribution. Awesome. So let's see how we can use it. Again, I've actually never used this before, so let's have a look. You can also access jokes in your own project by importing PyJokes. All right, let me just copy that. And using the function getJoke and getJokes. All right, sounds simple enough. Let's give that a go. I'm going to import PyJokes like that. And then what was the function? The function was getJoke. So let's do PyJokes and then say getJoke. And I can see that I can give it a language and category. So let's say getJoke here. So string is English. So we want the joke in English. And category, let's see. It says we can do neutral. What are the options here? Neutral is neutral geek jokes. No adult jokes for us. We can do Chuck Norris jokes. All right, neutral is fine. That's the default. So we actually don't even need to pass anything here, but just to be safe, let's do neutral. All right. Let's, I don't know what it's going to do, so let's just run this program and see what happens. All right, let's print out the joke. Let's say joke equals, and then say print joke. If I click run, real programmers can write assembly code in any language. Ha, ha, ha. All right, there's our completely useless package. Let's do another one. Let's see if there's any funny ones. How to explain the movie Inception to a programmer. When you run a VM inside another VM, everything runs real slow. All right, some of these jokes I'm sure are pretty funny. Some of them might be a little bit advanced, but hey, that's actually not bad. You know what? I might use this package in the future. I think this is fun. But I won't bore you with me keep pressing play. I might not record for a few hours and just waste time reading these jokes. But I just wanted to show the process of how I would go about doing something like this. Now, most programmers that don't use PyCharm, instead of doing what I did, will most likely use, let's say, their terminal to actually do this. So I have my Sublime Text here and my terminal or command prompt, if you're on Windows, right here. And if I do present working directory, again, this is a Linux and Mac command. So I see I'm on the desktop, which is where my 1.py file is. Now, if I wanted to use the PyJokes in here, and I click run, so let's say Python 3 1.py, module not found. No module named PyJokes. That's not good, but that's because we installed it for our PyCharm environment, but not for us to use outside of PyCharm. So how can we do that? Well, we can do pip to install from the pypi library or the repository. So again, if I go all the way up, you see that I have pip install PyJokes. So I can even copy this and just install it for myself here. Now here's the thing. Depending on how you have your machine set up, if I do pip-v with capital V, it's going to give me the version of pip, but you see here that it says from Python 2.7. We want to make sure we're using Python 3. So in your case, if you do pip3-v, you'll get the right version of pip. So make sure you check that and make sure that you're using with the Python 3 or higher. In my case, I'll have to call pip3. You can always set this up so that pip refers to the Python 3. But for now, let's say pip3, and then we're going to install. And here, all we say is the package name we want to install. In our case, it's the PyJokes package. All right. It's collecting PyJokes, successfully installed PyJokes 0.5. I also get a little warning here. You're using pip version 19.0.3. However, version 19.1 is available. And you might get this. And I always recommend just upgrading. So I'm just going to copy the command that they give us. And I'm going to say pip install upgrade pip. And I'm going to do pip3. All right, so I've successfully updated pip. So again, pip3v now has version 19.1.1. If I now, let's say, clear here and do pip list, I see that it shows me all the lists of the packages that I have. And if I scroll up here, I see that I have, where is it? Oh, I used the pip command instead of pip3. So let's do pip3 list. So this is something that you just have to be careful of. You can see pip3 list is looking a lot nicer. Let's see. I see that PyJokes is installed. Awesome. So now that I have this, let's run it. So I can run Python 3 and then say 1.py. Oh, what an appropriate joke. I swear I did not time this. This is just the programming universe telling us something. It says, friends, don't let friends use Python 2.7 because, hey, we should get this joke. Python 3 is the current and latest. Oh, that's funny. That's actually, I'm pretty pleased. I feel like we should end the video here because this is just perfect. All right, well, this is how you install packages with PyPI. We are able to really use the power of the developers all around the world using just a simple command, pip or pip3 install, and whatever package we want. across the world, across the internet, we have access to in our projects. I'll see you in the next one. Bye-bye. Welcome back. We've learned the true power of Python, and the true power of Python comes from the community and the fact that there are so many Python developers that we're able to leverage all these modules, all these libraries that people have built to really do really interesting things so that we can fast track our progress and build some really great projects really, really fast. Something that we're definitely going to do in this course. But you may have a question. This PyJokes that I just installed, this library, it has version 0.5.0, and this is called versioning in Python and in most programming languages, where the first number is usually a version where if you have bug fixes, you would go from 0 to 1 to 2 so that you update. 5 will be a new release, maybe some added features. And the last number, or based on how you look at it, the first number, the major number, is usually breaking changes or major versions. So PyJokes looks like it's fairly young. It's 0.5. But something like PyCodeStyle that is 2.5 looks like a mature library because they're in version 2.5. And here's the thing. Libraries are maintained by people, right? By programmers. We're constantly making mistakes. There's always going to be bugs. There's always going to be things that you can improve upon. So these are always improving. Versions are always increasing. And when you start working on large projects, you start installing different packages, different modules that perhaps only work with certain versions together. So that maybe PyJokes 0.5 is fine, but on a new project, 2 years from now, I want to use PyJokes. But the latest version of PyJokes, well, what can I do? In this case, I can uninstall, let's say pip3, uninstall the old version of PyJokes. So let's say PyJokes. And maybe have a new version of PyJokes that I can install. Now, when I do pip3 install PyJokes, this is going to give me the latest version. Or I could even do double equals and then give it a version like 0.4.0. So now if I do pip3 list, I have the older version of PyJokes. Now, the reason I'm showing you this is that sometimes you want for your different projects different versions of a library. Because maybe a project that you started 5 years ago really requires PyJokes 0.4, and this new project that you're starting requires PyJokes that's, well, let's say upgraded to version 2. So how do we do this? Because right now, the way we've installed things, there's only one version on my computer that I can use. This is what we use for what we call virtual environments. And it answers the question of, hey, how can we have two versions of all these packages, of all these modules on the same machine and still have different projects using different versions? Well, there's a tool that you can install called pipenv, which allows you to use pip and also this virtual env to install packages based on each project. So each project has its own packages. Or if you're using PyCharm, which I usually recommend, especially on big projects, you have virtual environments by default. Remember this venv folder? Well, venv folder is a virtual environment created by Python. As a matter of fact, let's say I want to create a new project. Here, I can create a project, let's say V or new jokes project. And here, if in the dropdown, you see that I have a new environment using virtual env. So I can use virtual env, which is built into PyCharm, to create a virtual environment. You also see that I have something called pipenv, which I mentioned. But usually you select the virtual environment, and when you do create, let's say this window is fine. When we do create, you'll see that New Jokes has its own virtual environment. And now any library that I install in here will have its own package right in here. So it doesn't affect any other projects. If I go to pyvenv.cfg, you see that the environment is set up with version 3.7. This is my home, and we're able to add packages right in here. And you see that, nope, I don't have any PyJokes in here because this is a new project with a whole new environment. If I create a new file, let's say in here, we'll say new file, and let's call it test.py. And let's say import PyJokes. We'll say PyJokes.get joke. What was it? Yeah, let's just copy this. And if I run this, whoop, I get an error. No module named PyJokes because I have an entire virtual environment. It's like a separate universe where I can install here whatever I want so that it doesn't interfere with the outside world. And usually when you're working on project, you want to create them in virtual environments like this. Again, this may not seem like a big problem right now, especially if you haven't worked in the industry, but this, trust me, is a common problem where packages are constantly being updated and you have packages that depend on other packages that need to have certain versions. So a virtual environment to contain all the packages that you use into your project, into this small little environment is really, really important. And as you start working for bigger companies, you'll notice that in your workplace, they're definitely going to be using this system. That's a lot of talking for me. Let's take a break, and I'll see you in the next one. Bye-bye. Welcome back. Now we're going to be spending a good chunk of this course building some projects and using some built-in Python modules, as well as using some popular third-party libraries from Python Package Index. However, I wanted to just show you a quick video on some of the useful modules that I personally like in the built-in modules that we have from Python. And some of these really useful modules actually allow us to have more data types in Python. Remember this list at the beginning of the course where I talked about the data types that comes with Python? And then we learned about classes and how we're able to create our own data types, our own objects in Python. But we also have these specialized data types that come as, well, built into this Python standard library, which are really, really nice. And this can make our programs really, really powerful. Now, they're specialized because you're not going to see them everywhere, but it's good to know that they exist, and I'm going to go over some of my favorite. The first one I'm going to show you is the collection module. So the collection module is from collection or collections. And there's three things that I really like here. So I'm going to say import. I'm going to import the counter, the default dictionary, and then the ordered dictionary. Now notice how some of them are classes because they're capital letters, and some of them look to be just a function. And you can read up on the collections module by just, again, scrolling through here and just looking at collections, and you can see all the ones that we have. So in these collections, let's start off with the first one. A counter is extremely useful. Let's say I have a list that contains 1, 2, 3, 4, 5, 6, 7. And I want to count how many items in a list. If I do print counter, you can see over here what it does. But essentially, if I give it a list and click run, all right, what just happened here? It creates a dictionary where 1 has 1, 2 has 1, 3 has 1. What if we add another 7 here? Let's say 7. If If I click run, did you see that? 7 now has 2. So what it does is it creates a dictionary that keeps track of how many times an item occurred in an iterable. So that 7 occurred twice, so 7 has a value of 2. Another way we can use this is, let's say we have a sentence. And say in the sentence, I want to check, well, let's just write something. I'll say, blah, 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 thinking about Python. If I was to do a counter here, and let's say give it sentence, if I click run, check that out. I see which letter occurred the most. In our case, H occurred 5 times, space occurred 5 times, and then B occurred 4 times. And this is really, really cool. Because this type of calculation of a counter, of turning an item like a list into what we call a hash map or a dictionary like this to keep count, is actually a very useful function that you see all over programming. It actually helps a lot with optimization problems. Now, we were not going to get into it there, but I just wanted to show you that counter is something that is really, really useful. If you want to count duplicate users or duplicate emails, counter can be really, really useful. What about the next one? Default dict. God, that's a really hard word to say. All right, so let's say we have a dictionary here, and this dictionary will have, well, a very insignificant dictionary. We'll have A1 and B2. What a simple dictionary. Now in here, I can say dictionary dot or bracket A, and I'll be able to grab the value, right? If I click run, oh, and I did not spell dictionary right. Let's fix that. That's better. Let's comment this out for now because we don't need this. You'll see that I get a value of 1. But if I try to access something that doesn't exist, like C, I'll get an error. With a default dictionary, I'm actually going to get a default value if something doesn't exist. So let's convert this into a default dictionary like this. And now if I run this, we get an error. First argument must be callable or none. So what default dict does is it allows us to access a key like this, but give it a default value. In our case, we need to give it something like a callable object in here. And callable means something like a function that can be called. So if I do run, I get 0. Why is that? Well, when I run int like this with nothing inside of it, we get 0. So a shorthand way, because this is going to be run, is to give it a quick function that we're not going to use. So let's just do a lambda and just give it, let's say, 5. So now if I run this, let's do dictionary here. Run. Oh, and let's try and grab something that doesn't exist. If I click run, I get 5. So this is a common pattern you see with default dict. We just give it a value or a callable object. In our case, we're just giving it this function, a lambda function, that simply returns 5. So I can even say in here, does not exist. The second parameter will be whatever we want. And if I hit run, I get does not exist, even though I'm accessing a key that, well, doesn't exist. Now, if I do A here and I click run, everything works. I still get 1. And if I do B, I get run as well. Again, another useful little data type. Next one is ordered dict. And this one is another interesting one. An ordered dictionary retains the order that you insert into a dictionary. Let me show you. So if we have, let's say, dictionary, and this dictionary will be an ordered dictionary. So this is how we create it. Now, in here, if I do D equals to A, and this is going to equal to 1, and then D, B is going to equal to 2, and I now copy this and make a second dictionary. Let's say D2, D2, D2. And I check, hey, print, does D2 equal D? Remember, this is going to check for the values. If I run this, I get true. Yep, they're equal. But if I change the order of insertion here, and I click run, I get false. Sorry, this is not the same thing because it maintains the order. If this was a regular dictionary, so let's say instead of what we have here, I'm going to just simply create a dictionary, and we'll just do a simple C here that has, let's say, 100, and do the same for this one as well. D2 equals to this. If I now run this, I get true because all the keys and values are the same. With a regular dictionary, we don't really care. There's no order. And I mentioned this before too, right? A dictionary in Python has no sense of order. Although when we print out the keys, we might get things in order. As our dictionary gets larger and larger, there's no guarantee that when we print out all the keys that we're going to get them in order. In the case of an ordered dictionary though, we get that guarantee. Now there are some performance implications for those. However, overall, it can be useful in some situations. All right, a few more to go through, but this video is getting long, so let's take a break and I'll see you in the next video. Bye-bye. Another really useful module that you might use actually quite often in your programming career is the date-time module. And as the name suggests, it allows us to manipulate date values, which is really, really useful. So let me just show you quickly how that would work. I can say from date, time, and in here, well, there's a ton of functionality, but you can do simple things like date, time, dot time, and give it in here some options. Oh, and make sure I import here like that. So that now, if I look at time, print here, if I click run, I get a time of 0. But if I, in here, let's say I do, the time is 5:45, and let's say 2 seconds. If I click run, I get 5:45 and 2 seconds. I get the time. So I can create time objects here, which is really, really nice. Another useful one is the date. And date gives us some really useful things, like today. Hey, what's today? Well, today, hint, hint, this is when I'm recording this video. So I get a date object that I can now use, which is really useful. Maybe a user signs up for your startup, and you want to make sure that when they sign up, you want to keep track of what day they started on. Maybe they got a membership and it expires in 30 days. Well, we can use the datetime module to keep track of that. And there's lots of things that we can do with dates. As you can imagine, there's things like time zones and different time data that we can manipulate. Very, very useful. I almost forgot this one, but remember when we built our decorator, our performance decorator that measures how long of a time a function takes? Well, we used a module here, didn't we? And this is another one of my favorite modules. It's the time module. And we can use it, well, like this. It tells us the time, and we can use 2 instances of the time to essentially figure out what the difference between the time instances are. Again, another really useful one. All right, I think we have time for one more because these videos could last forever. I could just keep showing you these, but like I said, these are modules that you're going to use whenever a need arises. You're going to start Googling and find out, hey, I need to get date information. Well, you're going to start Googling and find out that there's a date module or there's a date py package. All right, the last one is called an array. And we have an array package that we can use from, well, the array module. Now in here, what is an array? And this is something that I may have mentioned because lists in Python are sometimes called arrays in other languages, but they are a little bit different. You see, lists in Python are what we call just dynamic. That is, anytime we need data into a list, we can make it as big as we want. We can just incrementally increase this list and fill up our memory. And we've seen that before when we try to, let's say, print out a massive list. Arrays that Python gives us actually take up less memory and perform faster. So if you have a large list and let's say you don't want to use generators, you can improve it with an array. And that is because when we create an array, it sets how much memory we can use in our machine. Now, this is a pretty big computer science topic. You can learn about arrays online or some of my other courses. But for now, the way we would use it is like this. We'd say array, and we first have to give it a type code. So a type code with an array is what type of data is this array going to hold. And this is part of the optimization. By telling it what type of data we're going to hold, the memory is better used. So for example, if I go to the array module in here, you see that we have different type codes. And if I wanted, let's say, an integer, so that is, if I want a signed int, or maybe I want a float. And usually we want something like a signed int, so this is a Python integer. And it shows you what the minimum size in bytes is. But let's say we just want small numbers. So I can say, hey, the type code is going to be I. It's going to be a signed integer. And then I'm just going to give it 1, 2, 3. So now if I have an array like this, and I print array, if I click run, there you go. We have an array, but I can access it just like I would a list. Very, very cool. And this is a little bit more performant than lists. Again, if you don't want to use generators, if you have a massive list, this is a quick, easy way to optimize your code. The possibilities are endless. There are so many packages that we can use, so many built-in tools. The key thing is searching for it and looking for it when the problem arises, but there's no way that you can memorize all of these. As you progress through your career, there'll be certain ones that keep coming up that you'll just get used to, but you just have to trust me on this. This is one of those things that just comes with experience and as you code more and more. So the best way to learn these is to just keep coding. I'll see you in the next one. Bye-bye. Let's get into another developer fundamental, and that is pros and cons of libraries. You want to be careful with packages because it's not always good to use them. Now, what do I mean by that? Well, these packages are created by developers and programmers. You can have people that are creating really, really good packages, but also people that are creating bad packages that may be buggy and don't work well. So you have to develop that skill to make sure you're able to see, hey, this package is really popular, or this package is being maintained, or this library is really popular with the community, so most likely it's a good package to use. So this is a skill that you need to develop. Also, keep in mind that every time you add a library to, let's say, your project, you're adding more and more code, which means more and more bytes of data. So your project gets heavier and heavier and heavier. So that's also something that you want to consider. Before you're importing a library, ask yourself this: could I just write this myself? You usually want to pull in a library when writing something from scratch yourself is going to be really time consuming and you don't have the expertise in that area. At the same time, it's what makes programming so powerful, right? Because we don't have to start everything from scratch. And most of the time, when you're working as a developer, what you're doing is essentially matching and pulling in different libraries and getting them to all work together. A lot of your work is going to involve working with these libraries, reading the documentation of these libraries, and figuring things out as you go, as you try and build a useful tool by combining everything together. So there's pros and cons to everything. And this is just something that you will develop as you progress through your career. Just keep an open mind, be careful of using just any library, but also learn to read library documentation, learn how to use all these different tools to combine to create something useful. I'll see you in the next video.